Today, we're diving into some really critical fire safety science. And I mean critical because getting this wrong could lead to a catastrophic mistake. If you're the person responsible for picking out the right fire extinguisher, or maybe you're training a team that does, well, this explainer is for you. Okay, let's get right into it. If you're a safety officer, part of a fire watch team, or you're getting ready for hot work operations, you need to lean in for this. This isn't just theory. You see, choosing the wrong extinguisher doesn't just mean you fail to stop a fire. It can actually make it much, much worse. So yeah, we're going to cover how toxic gases can literally be created by the extinguisher itself, why some types were totally banned, and we'll get into the wild science of metal fires. This is the kind of knowledge that separates a real safety pro from someone who just knows where the red cans are hanging. Now, to really understand how any fire extinguisher works, or more importantly, how it can fail, we need a framework. In fire science, that framework is the fire tetrahedron. And trust me, it's the key to understanding everything else we're going to talk about today. You've probably heard of the old fire triangle, right? Heat, fuel, oxygen. Well, this model adds a fourth, absolutely crucial element, the chemical chain reaction. This is the engine of the fire. It's the self-sustaining process where the fuel breaks down, reacts with oxygen, and kicks out heat, which then keeps the whole destructive cycle going. So here's the big takeaway. Every single fire extinguisher is designed to attack at least one side of this tetrahedron. It's either cooling the heat, cutting off the fuel, smothering the oxygen, or breaking that chain reaction. If the agent you're using doesn't properly attack the tetrahedron for that specific fire, it can fail spectacularly. Remember this model. We're going to keep coming back to it. All right, so let's put this framework to the test right away. Our first case study is a once popular extinguisher that we now know has a very deadly, very toxic secret. Back in the first half of the 20th century, you'd find carbon tetrachloride extinguishers everywhere. We called it CCl4. On paper, it seemed perfect. It was a liquid that wouldn't burn, and it was fantastic at breaking the fire's chemical chain reaction and pushing oxygen out of the way. Sounded right? But it had a fatal flaw. Turns out, when you sprayed carbon tetrachloride onto the intense heat of a fire, the CCl4 itself would decompose. And in its place, it created a new, absolutely terrifying gas, Phosgene. And when I say dangerous, I mean it. Phosgene isn't just toxic. It was literally used as a chemical weapon in World War I. Its effects are horrifying. It causes severe lung damage, but it's delayed. Firefighters would use one of these extinguishers in, say, a small room, put out the fire, feel totally fine, and then die a day or two later as their lungs filled with fluid. So let's apply the fire tetrahedron. The CCl4 did its job. It successfully attacked the chemical chain reaction side. But the heat from the fire, another side of the tetrahedron, turned the extinguishing agent itself into a lethal poison. It solved one problem by creating a much, much deadlier one. And that is why it was banned. Okay, so that's a look at a historical hazard. Now let's pivot to a modern and just as dangerous challenge, the incredibly unique chemistry of combustible metal fires. We're talking about metals that can burn at thousands of degrees. Seriously, these are not your typical Class A wood and paper fires. The chemistry going on here is on a whole different level, and because of that, it demands a completely different strategy. So what do you think happens when you use a standard, everyday extinguisher on one of these super hot metal fires? Well, the results are often explosive. Let's break down exactly why, using our framework. So your first instinct might be to grab a hose, right? Water cools things down, it removes heat, but not here. A burning metal, like magnesium, is so incredibly hot and reactive that it literally rips the oxygen atoms right out of the water molecules. This triggers a violent reaction that releases a huge cloud of highly flammable hydrogen gas. So let's apply the fire tetrahedron again. You thought you were removing heat, but instead, that chemical reaction created a massive amount of new fuel, hydrogen gas, which then ignites, often causing an explosion. You didn't fight the fire, you just fed it. Okay, so water is out. Big time. What about a CO2 extinguisher? Its whole job is to smother a fire by displacing oxygen. But again, the intense heat of a burning metal is just too much. It's so hot, it can break the strong chemical bonds in the CO2 molecule itself. The metal just strips the oxygen away for itself to keep burning, leaving behind plain old carbon. It literally finds its own oxygen source. So if water and CO2 are not just useless but actually dangerous, how in the world do you fight a Class D fire? Well, you need a completely different kind of science, one that's specifically designed for this special hazard. Modern Class D agents are usually dry powders, and they don't just do one thing, they do everything. When you apply agents like sodium chloride or special copper-based powders, they melt and fuse together. They form this thick, airtight crust right over the burning metal, which smothers it. And at the same time, that crust acts like a giant heat sink, pulling a tremendous amount of energy out of the fire and cooling the metal. And that right there is the key to why they work. They attack multiple sides of the fire tetrahedron all at once. They remove oxygen by smothering, they remove heat by cooling, and by doing both of those things, they stop the chemical chain reaction in its tracks. It's a total, multi-pronged assault on the fire. Now, this isn't just some cool chemistry lesson. This is a critical workplace reality. Understanding the science has immediate, practical applications in a lot of high-risk industries today. Just think about where these hazards are popping up. Lithium-ion battery plants, EV manufacturing facilities, aerospace shops that are working with titanium and magnesium alloys. Heck, even simple metal grinding operations can create combustible dust. These hazards are becoming more and more common, and choosing the wrong extinguisher in any of these places is an absolute recipe for disaster. So we've covered a lot, but if you remember only one single thing from this entire explainer, I want it to be this next point. This is the absolute core lesson. I'm going to say that again. Fire safety is not about grabbing the nearest extinguisher. It's about understanding the chemistry of the fuel. That knowledge is your most important safety tool, period. Look, if this explainer helped you truly understand the why behind fire chemistry, not just memorize a chart of classifications, then you are someone who is serious about safety. For more of this deep, practical knowledge that really protects lives and careers, make sure you subscribe. Because at the end of the day, real safety isn't just about following rules. It's about understanding the science behind them.